Hey, this is Coin Guy Bry, and this will be part 2 of our Lightning Node series, our manual setup. Just for a quick recap of part 1, we introduced the RaspiBolt guide. We talked about some of the hardware required, connected it to the network, and did some initial configuration with host name, users, and some basic tools. Today the goal is to attach our SSD, and that's going to be storing the Bitcoin blockchain. To do this, we'll use our SATA connector to a USB 3.0 to connect to the Pi. We'll be formatting the drive, mounting the drive, checking that the connection between the drive and the Raspberry Pi is performant. And we'll change the swap file location for the SD card just for some maintenance stuff, and maybe we'll learn some Linux commands along the way. So to start, I will be connecting my SSD here soon to my actual Pi, so I need to get it. This is a 1 terabyte drive. I'll have the link in the description. So let's do that now. Again, this is the RaspiBolt guide. If you haven't seen this before, we did this in part 1. We talked about the setup and preparing that. So I definitely check out part 1 because we're kind of starting off right where we left off. So let's jump in here. So the first thing we're going to do, we're going to SSH in back into our node. So last time we did this, we set up a user called admin. So before we were doing pi at RaspiBolt.local. Now we're going to be just connecting to our admin. So we'll SSH into admin, and it's going to prompt us for the password we set for that admin user. So now we're in our Raspberry Pi. Let's do the next thing. So let's follow the guide here. So the first thing we're going to do is clear out some of the kernel. So the kernel is going to tell us some information once we connect the drive. So we're going to run these commands: sudo d message /c. That's going to clear out the kernel log. Alright, so now if I actually look at the kernel log, we can see it should be empty. Okay, cool. So now this next command, we're going to do sudo dmessage -w, and that's for watch. So it's going to put us in a state where we can just watch the log without exiting. So we're going to run that. Now I'm going to go over and connect my Pi to connect my SSD to the Pi. Okay, so I just plugged it in and we are getting some information here, so let's check this out. Looks like our vendor ID is, so we're going to take some note of some numbers. So let's look back at the guide. So you don't do this very often, so I'm not too familiar with this process, but let's see what it has to say. So it wants to take note of the ID vendor. So my ID vendor is 174C. So I'm going to actually just save these two numbers in a different terminal for now. I'm just going to put those there. In the ID product, and then we're going to Control C to kill the watch mode. Now we are going to list all the block devices by running lsblk. So we can see that we have this is our SD card, and it has 2 partitions. This is our actual drive. You can see it's about a 1 terabyte. But we do not have a partition for this setup. So let's go see how to set up a partition. So we're going to have to jump over to this other guide here. Alright, so to create a new partition, we're going to run the fdisk command. So let's run that as sudo fdisk /dev, and this was going to be the device name slash SDA. So, okay, so this is kind of like a interactive tool. So I'm gonna hit M for help. It says to hit M for help. So we get some commands here. So I think the first command we're gonna hit is N. So we're gonna create a new partition. N. We're gonna set up a primary partition. And we'll just give it the default number 1. Yeah, that's fine. We'll just use the default here, and we'll use the default again. So now we can hit the P command to kind of print the table of print our partition table. So that looks good. Let's hit so we can hit Q here, and it's not going to save anything, or we can hit W to write it. So I'm going to actually hit W. So now we can go back to the guide. So we should have a new partition. So if I run ls block again, we do. Okay, so cool. We have a new partition under our SDA device. So now we're going to test the read performance on this connection. And to do this, we're going to run this command. So I'm just going to highlight it here, shd parm/t direct, and then our actual device, or our partition. So it looks like we are getting 323 megabytes per second in 3 seconds. So that's fairly good. I think it says here they were getting 65 kilobytes. And we just need something more than 50 megabytes per second. So we are actually really good. That's a very, very good connection. So we don't need to do any of this part since my connection is very good. It wasn't more, I guess it was, I think it was about $100, so it should have been a very good drive. Now we're going to mount this, mount the drive. So to do that, we first need to format the partition, and we're going to use the ext4. I don't know what it's called. It's the protocol, or the type of file system it's used. It's the most standard, most up-to-date one for Linux. So to do that, we're going to run sudo makefs.ext4, and then the actual partition. So it did create the file system, so that looks good. Still working here. Okay, so that is done. Now it says we need to list the devices once more and copy the UID to a text editor. So let's kind of run the ls block command again, but we're going to pass in just some flags. So here's the ls block command, and we actually want to grab this UUID for this one. So this is the universal ID indicator. I'm going to save that in another terminal. Just paste it here once that loads up. Okay, so we saved that. Now we're going to edit the fstab file. So sudo. Now I use Vim. This one says to use Nano. I'll use Nano for now. I'm not going to be that quick at it. Vim is it's a little more advanced terminal editor to use, but if you're new to this, you're not going to be. Vim's going to be a little harder to teach, so we're going to use Nano to edit our files. So we'll run this command, and it wants us to add the following as a new line, replacing with our UID. So So it wants us to add this line to the end. So I'm going to add it right here. And we're going to change the UUID. Oh, what happened? To our new one. So copy this. Oops, that did not work. Again, Nano. I'm not used to Nano. Ugh. All right, 1 second. Let me. No, I don't want to save. I'm actually going to open this in Vim. I might have to learn Nano for the next one, but I can do this better in Vim. All right, so we need to add it here. I'm going to copy this line in. Paste in our UUID. Okay. Ooh, struggling over here. Come on. There we go. And we're going to. So I think that's how it needs to look. All right, that looks good. Let's just double check. Okay. So it should look like this. You're going to take your UUID and add it to this file, and then use the rest of these parameters on the same line. So we're going to save the file, and in Vim you can do :WQ. So now we can create the directory for the hard disk. So we'll do that by doing sudo make dir mount ext. Now we're going to mount the drives by running sudo mount -a. And we will run, so df kind of shows you your space in your system, all the hard drive space. So do -h mount ext. So we should see our drive. Yeah, our drive here is mounted. So cool. We are set up, and the drive is mounted. It's been formatted. It was mounted, and now it's just part of our file system now. So it is located at mount ext, and now we're going to set some permissions on this path by running chown or chown command. So sudo chown -r for recursive, and we're going to set the owner to Bitcoin, the group to Bitcoin, and the user to Bitcoin, and we're going to just pass in that file path. Cool. So now we're going to switch to the Bitcoin user. So now we are the Bitcoin user, and we can always double check this. It does tell me on mine right here, but if you don't have that on yours, you can always run the command who am I, and it'll tell you what user you are currently. We're going to cd into our new drive. Shouldn't be in. Okay, so we do have one file in here, but we're going to create a new one. Make dir Bitcoin to create a new directory, and then it wants us to show all the files in here. ls shows your files. -l, l puts it in this long format, like vertical. A shows you all the files, including hidden. So we are good to go. We look good. So now we're going to create a test file in the new directory and delete it. So we didn't get any errors, so we should be good to go. Now we're going to exit the current user. We can type an exit, or you can hit Control D. So we're back to our admin user. Now we're going to move the swap file from our SD card to the SSD. And the reason you do that is it's a swap file kind of holds volatile memory, and it can be kind of hard on your SD card. And the SSD actually handles a lot of read and writes a lot better. So to do that, we're going to run these commands. So we're actually going to go into these this file, dphys swap file. So you don't do this often, so I don't know some of these files. We'll try nano again. All right, so here it says we need to change the swap file location. And this is now going to be mount ext swap file. And then we're going to comment out the size. Now to save this, we do Control O for writing it, hit enter, and then we can hit Control X to exit it. Now we're going to run this, recreate the new swap file on the SSD. So to do that, we're going to run this command. So I think we are good to go. Okay, cool. So that's it. I know that was a little bit of didn't do too much explaining, but this is something you don't do very often, setting up these drives and partitioning. But if you followed along, again, there's the guide. I'm just showing you how to do it. Follow the guide. If you can't follow me, maybe you'll have some different changes. But that's it for this episode. It's just a quick one. We have all the storage we need to download the Bitcoin blockchain. The next episode, we're going to do a little bit more security and hardening the node before we do anything with Bitcoin. So that's it for today. Thanks for watching.